Hello once again, guys. We have come to the last section, which is part 3 of my complete guide in your mathematics N4 under the topic of trigonometry. So I have already done 2 lessons in that section, and the aim of this section is to ensure that when you come to that section of trig, you ensure that you get all your marks. So I thought 3 lessons might be enough for you to get kind of a whole idea what the mathematics N4 trigonometry is all about. So I hope this complete guide is assisting you, and as I said in the previous one, I will bring another mathematics N4, and this question, though it's not written here, it is I think it was written in 2014. I think it was April 2014. So this was a paper that was written in April 2014, and again it's mathematics N4. Now in this complete guide, what my aim, and again I reiterate, my aim is to ensure that you don't lose mark in trigonometry, because most of the students usually fear trig, but it is the simplest sections that if you master it well, you will get all the marks. Now before I move on to the lesson, do not forget to subscribe to our channel if you have not done so. If it's your first time to see these videos, I will encourage you to subscribe as well as like our videos. If you have a friend who's also studying towards their N4, forward this channel to them so that they can also benefit from these. The more you give us, the more you subscribe to our channel, the more students subscribe, the more of you guys comment and engage with us, the more we are motivated, or I'm motivated, to give you more of these videos. And actually it's joy for me to give you these videos. I feel more energy when you guys send me those reviews to say you're benefiting, to say thank you for these, if you can do this section, we will appreciate. And the more I get that feedback, I know we don't see eye to eye, we don't see face to face. Some of you have not even seen my face, but trust me, I feel like I'm closer to you through this mathematics, and if it's assisting you, I sleep better knowing that I helped someone out there. So get this channel to everyone that you think might benefit. Remember, it's not only mathematics N4, it's mathematics N1, N2, N3, N4, it's grade 8, grade 9, grade 10, grade 11, and grade 12. So if you know of someone who might benefit from this channel, just forward it to them, and I will greatly appreciate. So now let us look at this question under trig. So this is question 1, which is not question 2, also is not on trig. Question 3 in this paper, it was question 3. I think we noticed that in the current papers, trig is under question number 4. But in this paper, it's an old paper, and I said I'll bring something old and a little bit different in a way, but there is really nothing much different. And if I bring something old, sometimes they bring such questions which are very old into the question, so that students always feel like I must study the last papers that they've done, which is fine. You can get a trend of what the examiners are focusing on now, but go back to the old papers. It can give you a very good understanding and a full balance of these questions. And if you need a full set of these questions, unfortunately, we sell them in our previous papers. Just go through this after this channel. Go through the part where we write about this topic. You'll see there is a website called www.previouspapers.co.za where we sell a full compilation of papers from 2014 to 2020. And it's a single PDF download, and it's actually at a very affordable price. Alright, guys. So now let's get this thing going. The question here says, show that sine alpha is equal to cos that. Now the first part here, it's more like you're proving an identity in a way. One thing that they're trying to check out here is, are you able to simplify the right hand side? That is the main thing that they're trying to check on you. But now remember, the right hand side is easily simplified using a trig compound angles. This is a compound angle identity. So if I can go to the formulas, and in the formulas, we look at the formula for cos. As you can see, it says cos, and here we are dealing with cos 90 minus that sign there, which it's like alpha in a way, but it's not alpha. So it's cos A minus B, which is cos A cos B, and then if it's minus, you actually go for plus sin A sin B. So if I can write that down, what I'll be having in that, so okay, let me first write down that identity. It says cos A minus B is equal to cos A cos B, and then plus sin A sin B. That is what I'm going to use, and my question here says I need to simplify. I need to show that sine that or alpha there, to say sine, this sine is not really alpha but it's an open thing, is equal to cos 90 degrees, and then it's minus that sine, something like this. So that's what they're trying to that's what they want me to prove. So now I'm going to be using, as I said, this compound angle identity, such that if I simplify, let me take the right hand side here, and my right hand side is cos 90 minus that is equal to, if I match it with that here, it is equal to cos my A. You can see that my A here is represented by 90 and my B is represented by that side. So here it will be cos, in this case it's 90, and cos that side, then plus sine, it's 90, sine is that side, and then the calculator can actually give us the value of cos 90 and sine 90. So cos 90, you must know that cos 90 is equal to 0. As you can see, cos 90 is equal to 0. And what about sine 90? Sine 90 is equal to a 1. So what you have further, this is same as saying 0 times cos that plus 1 times sine that. So this one cancels, so you've got sine that, which is equal to my left hand side. So I've shown that this simplifies to that. So it was not a complicated question, it just, in a way, this is what we use to prove that. Remember, there is an identity here. That identity is a cofunction, and the cofunction says cos, you know the cofunctions, cos 90 minus theta is equal to sine theta. It's a cofunction. And also it says sine 90 minus theta is equal to cos theta, not cos 90, it's cos theta. So this is a cofunction that is actually you are proving there. Now let's go on to question, that was question 3.1, and that question 3.1, when you did that, you were just getting your 3 marks, which were not complicated. Now let us look at question 3.2. We've also looked at this again, and this is a repetition in a way. Kind of, if you follow up these from the previous 2 lessons, you'll start to now have an idea what this talk about. Question 3.2, it's 4 marks. Then they're giving you if cos A is that and sin B is that, and both angles A and B are acute. And we said when they say acute, it means they are in the first quadrant. Remember, calculate without the use of a calculator the value of cos A plus B. Now this question, the good thing about this question, if you can check it well, it's actually a follow-up, because we're still dealing with cos. Let me actually do this so that I don't erase everything. Some of the stuff is still valid. It is the compound angle identity that is still valid there. Now the only change is they are saying cos A plus. So I'm going to have a plus here, and then when there is a plus there, here it becomes a minus. So that is the compound angle from the formulas, and the question says I need to find cos A plus B. My question there is to find cos, and then I've got A plus B, which you can see is similar to just that A plus B there. So now the first thing is to draw those sketches, and this is the first sketch. Let me just do these two sketches like this so that you can have an idea when they are in the same sketch. So what I have here, remember when I'm sketching this, I've got, let me use this one here, my first sketch, and the second one, let me use this one there. So alright, I've got my sketch, and then the first one I'm going to sketch is cos A is 3 over 5. Alright, so I've got here cos A is equal to 3 over 5. So that's what I'm going to be sketching here, and just to separate like that. So what am I given? Remember, this is my y, this is my x, and when I do the dotted line there, I've got a 90 degrees there. This is my x, this is my y, this is my r. Remember that? Similarly, when I do it on the other side, I will have this as my y, that as my x. So when I do that, 90 degrees, I've got my x, I've got my y, I've got my r. This we are yet to find. But in the second one, they are saying it is sin B is equal to 12 over 13. So I've got here sin B is 12 over 13. So right, this is what I have on those. They say the question is if that and that are angles, both angles are acute, meaning they are in the first quadrant, calculate without the use of a calculator that. So first quadrant, that is where we're drawing everything like that. So now cos, you need to know what is cos. Remember, cos theta is equal to, in terms of x, y, and r, it is x over r. And sine theta is equal to y over r. This is your trig. So which means in this case the 3 represent the x and the 5 represent the r. In this case the y represent the 12 and the 13 represent the r. So that's what you need to know. So in the first one, in this x, what I have here, x is equal to 3 and the y is equal to 5. Now for you to find r, you need to use your Pythagoras theorem to say r is equal to square root. I can write it down for you just so that you don't, not to just to assume. Remember, this is a right angle triangle. In this case of this right angle triangle, let me show you what I'm talking about. I'm talking about this triangle and that and that. It's a right angle triangle where it's 3, 5, and you need to find r. So that's what I'm talking about there. So that you are having r is equal to square root, Pythagoras theorem, or the theorem of Pythagoras, 5 squared plus 3 squared. Actually, this is wrong. Let me correct that. In actual fact, I have my r. R is the 1 equal to 5. What am I doing actually? R is the 1 that is equal to 5. Let me correct that. Actually, because look at my statement here. I said 3 is x and 5 is r. So r is the 1 that is equal to 5. I need to find my y, not the other way around. So if I want to find my y, it's the same thing of Pythagoras. Y is equal to square root of 5 squared. Now it's minus 3 squared. Okay, so when you do that, you have 5 squared, square root of 5 squared minus 3 squared is 4. So you get that y is equal to 4. So that's what we have there, as our y is 4. So we have managed to find our y in this case. That's what we're solving for. Now let's move on the second one. Let us find our let me see what we're given. In the second one, we're given our y is equal to 12, our r is equal to 13, which means we are looking for x in the second one. So how do you find x? You do the same thing, Pythagoras theorem, whereby you are saying x is equal to square root of 13 squared minus 12 squared. Alright, which is equal to, when you check with your calculator, which is square root of 13 squared minus 12 squared, you get 5. So our x is equal to 5. So what I'll do is I come here and say x is equal to my 5 there. So this is now a full, I've completed all my triangles to be able to find that. Now, when I've done that, I then need to come back. Remember, the question says find cos A plus B. Now, when I simplify that cos A plus B, if I can just take it from there, it will be equal to, equal to, from the top, it's cos A dot cos B minus sin A dot sin B. Right, so now I need to know what is my cos A. We know what is the cos A part, because our cos A is, they gave us already, cos A is 3 over 5. So I'm going to just write that part, cos A here, which is equal to bracket 3 over 5. All right, I have to erase a little bit of that part because of my working, times cos B. Unfortunately, we are not given cos B, but we can find cos B from the second part. You see, in this side here, it can give me cos B. How can I find cos B there? Remember, sin B is this over this. So if I say cos B, now cos B is x. Remember, cos is x over r, as I did in this part. So cos is x over r. In this case, cos B, what is my x in the new diagram? X is 5. And then what is my r? R is 13. So it is 5 over 13. You see why we need to sketch that? Because you are supposed to find the x part using this diagram. So there I have got 5 over 13 minus sin A. I don't have sin A, but I can use this diagram here to find sin A. And how do I find sin A? Sin A, remember, sin is y over r, which is equal to, I did find my y, which is 4 over, and then the r part, we said here the r was equal to 5. So it's 4 over 5. So I can use that to say 4 over 5 here minus 4 over 5. Do that, is that dot sin B, which we have sin B, remember it is 12 over 13. Alright, so that is my sin B, and then my sin A, as I said, it was 4 over 5. So that is what we have, and it's up to you to simplify now. Remember, they say don't use a calculator, but you don't have to really not touch it as if you'll be found guilty, but just see what you can do without the calculator, and then the rest of the thing actually you can use a calculator. Like in the first one is 3 times 1, which is equal to here 3 over 1 times 13 will give me a 13 there. Or actual fact, let me not cancel because I'm noting something with the denominators there. You see, if I say 5 times 3 is 15 over 13 times 5, I think it's 65. Let me just quickly check. 13 times 5, it's 65. Okay, so I've got 15 over 65 minus 4 times 12, which is 48. Right, which is minus 48 over 5 times 13 is 65. So it's good because already same denominator there, 65, which is 15 minus 48. But are you noticing what I'm doing there? I'm using actually the calculator to find these values. I mean, you cannot prove that I was using a calculator to find this multiplication in that. Minus 53 over 65. So this is the value that they were looking for, and they said do not use a calculator. So that's the best that you can do for that. So cos A plus B is equal to that. Well, is there a way of trying to prove this? Yes, you can prove this. So what you do is find angle A. So in this case, you can come here. Where is our A? From this part. We can find angle A. Take a calculator. Remember, angle A is arc cos from here. Let me just show you. From here, I can find angle A. So what is angle A? A is equal to arc cos 3 over 5. And then I can also find B. B is equal to arc sine. I'm using that one there. It's arc sine 12 over 13. So let me find these angles and see what they give me. So the first one, arc cos 3 over 5, shift arc cos 3 over 5, and I think I'm getting 53.130. It's 53.130 degrees. And then what about the second one, arc sine that is 12 over 13, and then I've got 67.380. So it's 67.380. That is my angle B. So now the question is, I've got angle A and angle B. This question was find cos A plus B. So if I say here cos, remember this is my proof here, so it's not part of the working. So if I say cos bracket A plus B, in other words, I'm saying cos bracket 53.130, that is my A, plus B is 67.380. Am I right? So if I do that, let me see the answer that is going to give me. If I say cos 53, it's 53 there, comma 130 plus 67.380. When I do that, I get an answer of minus 0.5077. It's minus 0.508. Am I right? So it's minus 0.508. So this is what I have as the answer to what? To my cos A plus B. But now if I check my final answer, remember my final answer I got minus 53 over 65. So I want to see what is minus 53 over 65 there. If I say minus 53, because I left it as a fraction, over 65, and then you do SD, which is 0.8153. I think it was supposed to match. Let me see where I might have lost it there. I think I see where I lost it. I already see where I lost it. Look at the subtraction. 15 minus 48 is not 53. 15 minus 48, I don't know what I used to subtract, is minus 33, not 53. So you see the importance of checking now. I would have actually got it wrong just at the end, and and you find that I lose a mark after all the work I've done. So testing is always the key to me. I need to test. The reason why you see me all the time, I always emphasize on testing, is because I'm prone to errors, and because I'm prone to errors, I say to myself, how can I keep on testing myself that I'm correct as I work towards the math? So now, this is, see, I picked up an error there, and that error is minus 33 over 65, not minus 48. So if I say minus 33 here over 65, press SD, is minus 507, is minus 0.508, which is minus 0.508 minus 0.508. Now if I check, I think this is the same number, minus 0.508 minus 0.508. You see, these numbers now are matching. It means my answer was correct. It was just the last part where I made an error. So guys, this is how I would have approached that problem. So remember, it is this problem which was saying where you are given this cos and you are given this sine. Now you need to use the sketch. You have to do those sketches so that you can solve it. So now we have done the first two. Let us look at 3.3. Question 3.3. Now if I clear my board there. Now question 3.3 says simplify as far as possible. 1 plus cot squared x over cot x cosec x. You know, I don't think this was in a way complicated. I don't know why they gave this 4 marks. You know, sometimes they can just give extra marks. You wonder why is it that some questions they don't give more marks than the others, where there is a lot of working, but in others they just give a lot of marks. For example, this question was not worth 4 marks, but maybe if they'd given a little bit more there, maybe to become 5 here 3. You know why I'm saying this? Because by looking at it, I can actually picture the answer. Let me show you where the answer is. If I already have this 1 plus cot squared, if you go to the formulas, you see I have on the formulas this 1 plus cot squared. See that? So what is 1 plus cot squared? It is cosec squared x. 1 plus cot squared x is actually cosec squared x. So I can literally come here and say from here this is equal to 1 plus cot squared x is cosec squared x over cot x cosec x. That is where I'm actually saying I don't know why they did that. Now if I just now cancel off that cosec, 1 here will remain, so that here I will have cosec x over cot x. Just think of it. That was the reason why I was arguing that. Now you know what is cosec. So this, because I want to get rid of the way it is happening, here I will have equal to cosec, I will write it like this, cosec x divided by cot x, which is cosec is 1 over sine x divided by cot. Remember, cot is cos x over sin x. You know what I mean? Then you can move on to say 1 over sine x. Then you introduce the times. Then you invert. Remember, when you do the times, you invert. It becomes now sine x over cos x. You know what I mean? Then this is just plain algebra in trig. Then you cancel that, you cancel that, you have got your answer as 1 over cos x. You know what I mean? So this is 1 over cos x, but now 1 over cos x is, remember 1 over cos is same as sec x. You know, so this question simplifies to become sec x. Look at the working. I mean, I was taking it long just because I was taking step by step, but the 4 marks here, I don't think it was really worth it. But anyway, it's a bonus if ever you are working on this, so that you make sure that you don't fail that paper. So this simplifies to sec x. Now, how do you check it? Okay, choose any value of x. For example, let's say x is equal to 20, right? Then you go with the calculator and you put these values. Now you must see how I use that. So it's 1 plus, there is no cot in the calculator, but cot is 1 over 10. So I put a bracket and say another fraction, 1 over 10. Remember, cot is 10. I said x is 20. I do that. Then close it with a squared. And then after that, cot again is 1 over 10. So you do that in F, 1 over 10, 20. And then play forward times. Cosec is 1 over sine. So it's 1 over sine again 20. You know, I'm trying to check if my answer is correct. The answer I'm getting is 1,064. Here I'm getting 1,064 if I didn't forget that. Now let's come here, and where there is x we also substitute the 20. Now sec is not in the calculator, sec is 1 over cos. Remember, so this is 1 over cos 20, and then it must still give me that answer, which is 1,064, which is exactly 1,064, which is what I got in here. So these are testings that I use, but remember, you must not show us all this part, because it's part of the work that you do roughly in your rough work. I mean in your rough work, not roughly in your rough work. You do this rough work in your rough work side, where like at the question paper itself or at the back of the book, after you have done it, you cross it out to show that it was just rough work. So this question was all that was needed here, and guys, for 4 marks, I think it was a big bonus. You know, when you also have to at times smile to the one who gave you this question to say thank you, you know. Now this was 4 marks. Now let's look at the other one. This question that is following is 5 marks. It says solve for x if, I can make it smaller so that you can see it in full. It says solve for x. Here now, it says solve for x, that's 3.4. Solve for x if, so this solving x, if you are given this. I think you can see that. It's 5 marks. Well, such questions, I think they are worth 5 marks if you have been working with trig. So it's 5 sin squared x. Let me write it. So you are given here 5 sin squared x, all right, and then minus 5 cos x, minus 5 cos x, all right, is equal to minus 3, is equal to negative 3, and then they gave you that part to say 0 is less than or equal to x is less than or equal to 360. These are the range of values of x in which the answer is, or the solution is possible. If I can just use a different one, 0 is less than or equal to x is less than or equal to 360. Now, how do we approach that one? The first thing you need to do is to try to solve this. You cannot solve that sine and cos at the same time. It's not possible, because at the end of the day, you have to solve for x. So different cos means either you have got 2 equations that you can solve, but if you have got sin, you need to either convert it to cos, or if you have got cos, you can convert it to sin. Now you have to use your trig identities, and the one that comes into mind that is more appropriate here, it is the first one. I mean, this is your fundamental trigonometric identity. Sin squared x plus cos squared x is equal to 1. So that's the one I'm going to use here to say, I will use just to say sin squared x plus cos squared x is equal to 1. But now I have got sin, I want to remain with cos. Actually, I want to remain with sin on one side, so that I've got sin squared x. I want to write everything in terms of cos. You see, it's 1 minus cos squared x. So you see why I'm doing it? I'm doing it so that I'm going to substitute where there is sin squared. I'm now going to say this is 5 into, then I'll write that thing which is now sin squared, which is 1 minus cos squared x. That's the reason why I'm doing that. I'm saying that minus 5 cos x is equal to negative 3. Now check this. Everything now is in terms of cos. Then I have to open that bracket, which is 5 times 1 is 5, minus 5 cos squared x, and this minus 5 cos x is equal to negative 3. Then you have to collect your like terms and everything, so you'll have minus 5 cos squared x, alright, minus 5 cos x, and then you have got to have your plus 5, then the 3 join so that you've got plus 3, then this you equate it to 0, you understand? So that you've got minus 5 cos squared x minus 5 cos x plus 8 is equal to 0. Now it's up to you how you want to do it. You can get rid of that negative and distribute it, or you can leave it like that and have to say this is your A, your B, and your C. And you know what I'm doing? I'm now substituting in the quadratic equation. Remember, it's a quadratic, cos squared, cos x, and 8. Quadratic equation, x is equal to minus b plus or minus square root. Let me just check if they give you a quadratic equation in this formula sheet, because you need to know your quadratic equation. So guys, there is no quadratic equation here. You need to at this stage know it by head. So it's minus b plus or minus square root of b squared minus 4ac all over 2a. Then I have to do my substitutions, and then it will be x is equal to, now my b is negative 5, so it's minus 5 plus or minus square root of b squared is minus 5 squared, minus 4, my a is negative 5, my c is 8, and then everything is all over 2a is negative 5. Alright, so it will give me two values of x, which I will use the calculator there to say. With the calculator is minus 5, start with the positive one, plus square root of bracket negative 5 squared minus 4 bracket minus 5, for AC is 8, and then everything over to negative 5. Are you seeing that, guys? And when I do that, I get my first value, x is equal to minus, if I do to 3 decimal places, is minus 1,860, but you can do the calculator shift setup, not that, sorry, say answer again equal to, so you say, anyway, let me start it afresh because I need the other side of this. So I say it is minus, anyway, it's fine, there is the answer. Let me do my STs. If I say shift setup, then 6, which is fixed to 3 decimal places, press ST, is minus 1,860. See that one? X is equal to minus 1,860, or x is equal to, just that I have already removed my working, so I must start this afresh. I should have played back there, minus bracket minus 5, and then the first one I was supposed to do it like this. If you're using a calculator, you don't have to do this twice. Minus 5 squared minus 4 into minus 5 minus 4a, and then my c is 8 over 2 into negative 5. So this was the first one that I got. Remember, press SD, then play back to change there. That's what I wanted to have now in negative. You do that, press SD, you get that one, shift, setup, 6, and to 3 decimal place. And then you press SD again, is 0,860. 0,860. We've got two values of x, either x is that or that. But now, what you always know, if you are working with trigonometry, any value of x that is bigger than -1, so that you need, remember, you need to say a cos here. If you say shift a cos minus 1,860, you see that it will give you an error. So this one is invalid. So you must write invalid. So the answer that you're going to deal with, you're going to say the answer there is this one for x is equal to 0,860. So how do you find your answer? So you are saying here, I know here you are finding x, but let me change this because it's now confusing. Let's say this is not x actually, what we're finding, this is cos x, you know, this is cos x. So it means cos x, you better name it maybe y or whatever, but this is cos x. So what we're saying is here, cos x is equal to 0,860, such that when you want the x now is equal to arc cos, you see what I mean, 0,860. So you're going to have two different x's that we're going to give some confusion. So when you do that, you say shift arc cos 0,860, then you get the angle now, which is 30.683. It's 30.683. So this is the angle that you get. Now, since our cos is positive, see the sign there means, if there is no sign there, it means it's positive. So we've got x is that, which is the first quadrant, which is fine. Or remember, according to your cast diagram, if I can quickly do this, according to your cast diagram like that, this diagram. Now, according to the cast diagram, one thing you know is all students take chemistry, and cos is this is quadrant 1, this is 2, this is 3, and this is 4. And cos is positive. We're dealing with cos. Cos is positive in the first one and in the fourth quadrant. And in the fourth quadrant, it's 360 minus theta. Grab hold of my lesson on this in Maths N3 and the other previous lessons in the N4. I've actually detailed this. So your other answer will be or x is equal to 360 minus the first one, which is 30,683. Like that. So your answer therefore becomes in this case it will be 360 minus 30,683. Then you get the other answer, which is 329.317. 329,317. So these are the two values of x that they expected from you. Why am I using that? Because they told you the range there is between 0 and 360. So it's a complete cycle or circle. It's hence I used either x is that or our x is that. So that's how you solve such a problem in trig, which is involving a quadratic equation. And I hope these guys, in the previous lessons I didn't touch I think much on this, so this is one unique side that I think you might be benefiting from this. And remember guys, if you are benefiting from these lessons and if it's your first time, subscribe to our channel if you have not done so, and also remember to like our page or to like our videos. And also you can press that notification sign after you subscribe. There is that little thing like a ring, whereby it means that when we post new videos, you will be notified that there are new videos that we have posted. It can always keep you updated with your studies. So if you also have got some colleagues who are studying the same subject, you can forward them our channel so that they can also subscribe. So lastly guys, let us look at the last one, which is 3.5. We are done with 3.4. Let us look at 3.5. 3.5, it says prove that, and we're supposed to prove that this is equal to that. And again, when I noticed this, I think for 4 marks, just think of it, this thing was worth 4 marks. Let me just show you. I mean, it was worth 4 marks there, but I feel like, again, just like the one that I told you about, this one, I think it was worth less than that. But because it was a question paper for students that I like you, I think it's a good bonus for you. I wish they would bring more of these, you know. So now look at this. It's actually, when you're used to your trick, you can literally see the answers through. Now, why am I saying that? You see, sine 2y, this one, it's a double angle, which is 2 sine y cos y. And you can see now I've got that cos, I'm going to factorize, giving me the top. Let me show you what I'm talking about. So I have 2 sine y plus 1 over, so here I'm starting with what? I'm starting, remember, I'm proving. So I'm starting with the left hand side. Left hand side, it's not clear there. Left hand side. So that's what you need to tell us. So I've got 2 sine y plus 1 all over, this one is said it becomes 2 sine y cos y, and then it's plus cos y. You see that? And then, as I said, you factorize what's common, so which is 2 sine y plus 1 over sine y, I mean not sine y, but it's cos. Cos is common there, so you take out cos y. So you've got 2 sine y plus cos y into cos y is 1. Hence you see me kind of saying this and this, that's the major thing that was being done there. So you've got 1 over cos y, think of it, and then 1 over cos, remember it's what? It's sec y, which is equal to my right hand side. I mean, it didn't take you long, even in your mathematics N3, just that they don't deal with double angles anyway. So here it was just testing you if you can recall this double angle identity. When you could do that, that was the main reason they were trying to test you on there, and it was going to be straight like that. Now guys, that was all on question number 3.5, and the total of this section was out of 20 marks. And if you can see the way I was working on it, you can see actually it's not difficult for you to get the total of all the 20 marks when you're working on this trick. I hope these sections are benefiting you. Remember, it was trigonometry. As I said, I'm giving you kind of a full picture of what these trigonometric questions usually come like in your final exams. And if you can look at part 1, part 2, and this is part 3, I bet you they will benefit you if you are doing your mathematics N4. And also remember to subscribe to our channel. I cannot overemphasize, it gives me the motivation to keep on bringing you these videos, because the more you subscribe, the more Google will show you these videos so that other guys can also benefit from these. Guys, we've come to the end of our lesson. Thank you.